Managing the Oracle Instance Part 1 of 2. We're going to begin this nugget by learning about the phases of Oracle database startup and shutdown. There are many real-world scenarios that will require that you shut down the database, so we need to understand all of those phases. And there's more phases than just simply start up and shut down. Those Oracle engineers have thought of everything. I have undying admiration for them. We'll also cover initialization parameters. This is the main way that we as database administrators can customize the behavior of our Oracle instance and Oracle database. Without any further ado, let's get started. Our book of the nugget is this one. And you know, to my mind, one hallmark of a quality information technology textbook is whether or not it's gone into multiple editions. Generally speaking, a book that's not well written or not successful is not going to go into the second or third edition, much less the fourth edition. The book I recommend to you at this point is Oracle Essentials by O'Reilly Press. Rick Greenwald et al. Are the authors. I've read this from cover to cover. It's an excellent introduction to Oracle, and it supplements the training that you're getting from me really, really well. Now, because it's gone to the fourth edition, you want to make sure to purchase that edition, because earlier editions of the book cover earlier releases of Oracle database. Remember, we're concerned with 11G, and there's been quite a bit of change in between even 10G and 11G, much less 9i to 11G. So check it out. It's very clearly written and contains excellent information. Let's take a look at Oracle database startup flow, shall we? When an Oracle database starts up, you remember, just as a preliminary bit of information, that we have the instance, which are the memory structures and the background processes supporting the database, which consists of your core files, your initialization parameter file, your control file, your data files, and your redo log files. Well, that's what we have here. In step one of the startup process, Oracle needs to find an initialization parameter file. Now, there's two varieties of initialization parameter file. There's the SP file, or the server parameter file, and then the old school P file. We're going to talk about the parameter files in greater detail later in this nugget, but for now, let me say that your best practice is to always make sure that the Oracle database is starting using SP file. There's many advantages. The chief one being that the server parameter file is a dynamic file. We can make changes to those initialization parameters while the instance is running, whereas with the P file, which is just a plain text file, any changes you make there will require restarting the database. And if your company is heavily reliant upon Oracle database, it's not a trivial thing just to bounce or restart that database instance. Now, the SP file gives the Oracle instance and the Oracle database all its operating parameters, all of its properties. You can kind of look at the SP file as somewhat equivalent to the Windows registry. Windows is not going to run if there's a registry problem, if there are invalid or seriously critically invalid entries in there, or if the file's missing. When we load the SP file, we then search for and find the control file. As a matter of fact, logic would tell you accurately that there is an initialization parameter called control file that will tell Oracle where to find the control file. Now, as we have already discussed, the control file is a binary file that gives Oracle full intelligence as to the database. The server parameter file is kind of an instance/database registry. The control file has specific information regarding the active database. In other words, where are we going to find our data files? Where are we going to find our redo logs? I want you to see a couple major themes here in this startup flow. That the control file and the redo logs are intended to protect the data file. Remember earlier when we talked about background processes, the database writer, the log writer, and the checkpoint process? You'll recall that when a checkpoint occurs, the database writer writes any dirty buffers, and dirty with regard to Oracle database refers to data that hasn't been committed to disk yet. It's existing only in memory and is therefore volatile. So during that checkpoint, the database writer writes its dirty buffers from the database buffer cache to the data files where they're going to be permanently recorded, and the log writer process writes writes redo information, remember that's the SQL statements that produced those dirty buffers, to the redo log files. All of that is to protect the data files, isn't it? Such that if we have data file corruption and we need to restore that data from backup, we can make use of our redo log files. We can make use of our control file, which contains our checkpoint information, in order to resurrect that data. Because the control file and the redo log files are so crucial to protecting our data, we need to make sure to multiplex both the control file as well as the redo log files. Multiplex is one of those funky words, kind of like schema, that can have different meanings depending upon context. The only context we're concerned with here, of course, is Oracle, and multiplexing means to maintain redundant copies of those files. As a matter of fact, a little bit later in a demo for this nugget, I'm going to show you how to multiplex the control file, which puts the control file copies or mirror images on separate disks such that the failure of a file will not bring down the database, much less the failure of an entire disk won't bring down the database. Let's take a short pit stop and consider the database listener and database control. If you've been following these nuggets sequentially, and I certainly hope you have, you recall that during our initial instance installation using the Oracle Universal Installer, that we took a pit stop then to create the database listener. A database listener in Oracle terminology refers to the specific TCP/IP socket. Now, it doesn't have to be TCP/IP. There are other protocols supported, including interprocess communications. If you're, for instance, not working in a network environment, you have a development instance and you're accessing it always locally, interactively at the keyboard. But traditionally, we're talking about a TCP/IP network, and a socket in TCP/IP terminology refers to the unique combination of an IP address, a DNS host name, and in this case, a TCP port number. Now, we're throwing in one more bit of information for the listener, and that's the Oracle SID environment variable. Remember, SID doesn't refer to security identifier like it does in the Windows operating system. In Oracle, SID is a service ID, which is in 99.9% of cases going to be the name of your database. And you want to keep that name as short and simple as possible. In this training, I'm using Oracle, ORCL, as the example database name / Oracle SID. Now, that listener process, the settings for which are stored in a text file called listener.ora, allow the Oracle server to listen for incoming connection requests by users. Therefore, the users for their end are going to need some mechanism to resolve the address of the listener. Now, I'm getting a little bit ahead of ourselves because we're going to be talking about OracleNet later in the course, and we'll learn about things like the tnsnames.ora file that is on the client computer, etc. For now, just understand that we need at least one listener on our Oracle server in order to host incoming connections. And that listener is used not only for client connections, but also for our hypertext transfer protocol server, our HTTP server, which we've used quite a bit. That's Oracle Enterprise Manager, also called Database Control. Now, as far as configuring the listener, you can go the graphical route if you want to using the Net Configuration Assistant. This is what we used in the earlier demo when we installed the instance. If you're more of a command line person, you can use the listener control utility, and I've given two simple examples of its usage: listener control start, listener control status, and optionally the listener name. The default first listener name is listener, so it's easy to remember. Now, with regard to fault tolerance and performance tuning, you may decide to bring up a secondary network interface card, or NIC, on that server, such that the failure of one will not bring down the other. In that case, you can configure multiple listeners. This can be useful, again, just to provide some extra fault tolerance in your connections. With regard to the database control web server, you can control it using the command line emctl utility. And again, the syntax is pretty straightforward: emctl start DB console, stop DB console, or status. And by the way, listener control also has a stop action too. And then finally, there's a tool, command line tool called EMCA. That's the Enterprise Manager Configuration Assistant. And you can use this command line tool to make tweaks to your database control web server, like changing the Enterprise Manager port number off of what they give you initially. In this demo, we'll have a look at the Oracle Listener. Let's cut right to the chase by opening a Windows Explorer window and navigating to Oracle Home Network Admin. This is the default location of listener.ora. I'm going to right-click this guy, and I'm going to open it up in, let's use WordPad here. WordPad tends to handle line breaks better than Notepad does in Windows. So this is the actual Listener Aura configuration file. Now what's going on here? The centerpiece of this file is the section in the middle. This is my active listener, and it doesn't have to be, by it I mean the listener. It doesn't have to be called listener. That's just the default name. And then within that heading, we have a description list of protocols. In this case, I'm enabling inter-process communications with a key value of IPC. The main one for TCP/IP networking sake is using transmission control protocol. Host name is Aura Nugget, port is 1521. So you can modify the text file if you want to, but Oracle gives us a couple nice additional utilities that we can use. Remember, there's the LSNR, listener, CTL, and we can run listener control status as long as you have the listener control in your search path as previously discussed. And this gives you a nicely formatted report. Looks like because I am logged on to the server interactively, I'm currently connected via inter-process communications, which is fine. But status tells you, for instance, the name or alias of the listener, what its uptime is, if you've enabled tracing for diagnostics or performance tuning, whether that's turned on, security, and then the most important section here is the endpoint summary, where it gives you the specific info that we already saw in listener.ora that says we're doing for network sake TCP Aura Nugget 1521. Now I mentioned that a socket consists of a unique IP address, host name, and protocol port address. This Aura Nugget host value, it's assumed, is in DNS, such that other users on the network can get to the host name that way. Cool. You'll also recall that there's some graphical utilities. If we open our Oracle Home folder, open Configuration and Migration Tools, we have the Net Configuration Assistant and the Net Manager. I'll open up Net Manager first. This is a Java application. It doesn't look like much, but it does the trick and contains a section for listeners. Now you can bring up additional listeners by selecting the listeners node and clicking the plus button. Alternatively, we can reconfigure an existing listener by selecting it, and then there's a tab here depending upon which protocols you're using. There's our TCP/IP option, and we can change the host name and port number if we want to. If you're more into a wizard-based approach for configuring these things, we can go again back to Configuration and Migration Tools and use the Net Configuration Assistant. This kind of takes you by the hand a little bit more, where we can customize several different things. We'll talk about these remaining three options later in the course, but for now we can do a listener configuration if we want to. We can add a listener, reconfigure a listener, delete it, or just rename it. I'm going to choose reconfigure. We just have the one, so this control doesn't actually open. Now it tells us here that the listener is currently running, and in order to modify it, Oracle will need to stop the listener temporarily. I'll choose yes there. And then we're just simply asked the same questions that we had the first time we went through the Net Configuration Assistant to bring up the listener. Which protocols do we want to use, etc. I'm going to actually bail out of here because I'm fine with the way my listener is currently set up. Finally, let me just show you from an elevated command prompt, EMCA utility, the Enterprise Manager Configuration Assistant. This enables you to customize the performance of the DB control utility, or DB console as it's often called. For instance, if we wanted to change the HTTP port that's used for the website, which is by default on my system 1158, we could run the command EMCA with the flag reconfig ports, and then there's the property itself is db control underscore HTTP underscore port space and then the name of the port. So I could change the port to something non-standard like 1971 by running this command. I'm not going to do that because I'm perfectly okay in this development environment using port 1158. Phases of Oracle database startup. You'll recall that at the beginning of this nugget, I expressed my admiration for the Oracle engineers. I'll tell you, they really have thought of just about everything with regard to what is helpful for database administrators and database developers to get their work done easier. Instead of just start up and shut down, there are actually 3 different phases of database startup for Oracle database, and you may need no mount or mount versions besides the traditional open, in which the database is open for user connections. There are certain recovery scenarios that require the database, or instance I should say, to be started to the no mount phase. By contrast, there are recovery scenarios, specifically full database recovery, that require that you start the database instance up to the mount phase. So again, it's thoughtful of Oracle to give us this incremental open process. Now let me describe what happens. When you start up a database in any of these methods, no mount, mount, or open, the first thing that's going to happen is that Oracle needs to pull itself up by its bootstraps. Similarly to how a computer is going to read BIOS information or EFI startup information, the Oracle instance is going to look for a server parameter file or just a standard text P file. Now again, I'm going to show you how to determine which your database is looking for first and how you can change that. But certainly, I'm going here to convince you, you want to use the SP file every day and twice on Sunday. It just has so many more advantages than the old school P file that's there basically for backward compatibility. Once Oracle Instance locates the SP file, it gets intelligence as to all initialization or startup parameters. A parameter is simply a property. It's going to determine the running state of the Oracle instance and the Oracle database. So we have things like automatic memory management that gives Oracle the memory target ceiling, or if we're deciding to do manual shared memory management, all of that information stored in the SP file, so Oracle can allocate the system global area and can start up those background processes. So at this point, at no mount, the instance itself is started. Any auditing that's configured, alerting, tracing, that stuff gets brought up as well. So your engine is started by the time startup reaches no mount. Now if we're continuing, if we're doing just a standard startup that's going to terminate in an open, the intermediate stage is to mount. Now there's a difference in Oracle with the database in terms of it being mounted or actually open. At the mount phase, the database is located. So you know, I hope, that we need the control file in order to get to the database. So in summary, no mount mode requires the parameter file, mount mode requires the control file. The control file gives Oracle the intelligence to find the data files, the redo log files, and at that point we're ready to proceed to the open phase. The open mode requires the database files, the data files, as well as the online redo log files. As long as those files are located and they're okay, they're not hopelessly damaged, the database is either going to go into recovery mode if, for instance, you did a hard shutdown due to a power failure or something, in order to bring up synchronization, to make sure there's synchronization, I should say, between the redo log files and the data files. But all things being equal, the database is then open for business, the listener is open and ready to receive user connections. And with regard to those consistency checks that happen not just initially at the open phase, but periodically throughout the uptime of the database, the system monitor or SMON process is required to do those housekeeping tasks. As users connect, the PMON process comes into play and monitors those connections and cleanly cuts off any that were broken in a dirty fashion. The final thing I'd like to say at the moment about database startup is you get to these phases by using the startup SQL plus command. If you issue startup with no parameters, then it's assumed, we're assuming that the instance and database are closed, that we're going to go all the way to the open phase. If you want to stop at no mount, you do startup no mount. If you want to stop at the mount phase, you do startup mount. Now let's take a look at database shutdown. Database shutdown also is a stagger step approach where we have 4 different levels of database shutdown. Now, if we're at an SQL prompt and we just type shutdown, that's going to be a shutdown normal shutdown. This is the default. Alternatively, you can type shutdown normal. Now, this is the cleanest and most reliable but slowest database shutdown method. What happens here, and this is definitely an exam alert, I tend to throw an asterisk up on the screen when we hit subjects that are very likely to be covered heavily on your certification exam. You need to understand how these shutdown modes affect existing connections. Now, with a shutdown normal, existing connections are allowed until they terminate. That can be a slippery slope if you have scheduled downtime or scheduled maintenance for the database and someone leaves their connection open when they go home at the end of the workday. You see what I'm saying? So there's some communication required on your part as a DBA as well as some finesse. The shutdown immediate will kill all sessions, but roll back any uncommitted transactions, and Process Monitor is involved in that cleanup, working in conjunction with System Monitor. So this means any users who are on that system or logged into the database, boom, get booted immediately, but we still have data integrity. Any committed transactions submitted by the user are forwarded to the data files and the online redo log file. Any transactions that are in process and haven't yet been committed get rolled back by means of the undo data that Oracle 11g stores. Okay? Transactional is a third database shutdown method. What happens here is that existing sessions without transactions are killed. Others can continue. Transactional, I think, is a kinder, softer database shutdown method than immediate, which just kills all sessions. Here, folks who do have active transactions can continue. Sessions that have commits are killed. Now, you're probably wondering, as we discussed these three database shutdown methods, what is going to happen with new incoming connections? We're talking about preserving existing connections, at least in two cases. What about folks who want to log into the database while the shutdown happens or after the shutdown happens? Well, the bottom line is new connections will not be allowed, and hopefully that makes sense to you intuitively. So we have the super kind shutdown, the kind of in-between shutdown, and then we have the immediate shutdown. What is abort? Abort is your last case scenario. It's really a drastic way to shut down the database. You really want this to be your very last resort. If you just can't get the database shut down using another method here, then you can try database abort. This is equivalent of the force quit command that we have in all current operating systems. The reason why this is drastic is that it kills all sessions regardless of whether there are uncommitted transactions, and even more drastically, there's no rollback. It's just a dead stop. It's almost equivalent to just unplugging the computer from its AC wall socket. Let's examine database startup and shutdown. I'll open an elevated command prompt here and we'll clear the screen. We're going to log into SQL Plus. First, I'm going to just come in initially and not log in. When you do an SQL Plus no log, you're not actually connected to the database. So if you run even an SQL Plus command, certain ones anyway, like help, you'll notice that I received an error message that the help system isn't available. It's kind of tricky. The reason why that's the case is that Oracle keeps the SQL Plus help documentation in the database. So there's not a whole lot you can do in a no-log situation. I'm going to connect as the sys user, and you need to be connected with the sys DBA privilege in order to do things like starting up or shutting down the database. That sys DBA is absolutely crucial. I didn't mention that earlier. I guess now is a good time to mention it. Let me enter my password, and now I'm connected, and if I run help, we get access to the command line help system. But anyway, sys DBA is the super user privilege and is required, that or sysoper, in order to do database startup and shutdown. It's just one of those fail-safe mechanisms. You don't want a new DBA on staff logging on without sysdba and being able to shut down the database. That's not a good thing. So we protect sysdba as well as the sys account big time in Oracle, and we'll talk about Oracle security later in the course. Now, while we're here, when you type help, I'm going to take a little pit stop here to sprinkle in some SQL SQL Plus tips. I hope that if you haven't taken my CBT Nuggets training on the Oracle SQL Fundamentals exam, that you do that immediately or soon, because I give you a very full rundown of how to use the SQL Plus utility specifically. Anyway, help index is going to give you a run of all of the not SQL commands, but SQL Plus internal commands that we can use. And you'll see, of course, shutdown is one of those options. So we can type help shutdown to receive a little bit of help on it. And it tells us here, shutdown abort, immediate, normal, or transactional. Help shutdown immediate. Unfortunately, the help doesn't seem to go into the keyword section. A little bit disappointing. Let's run a shutdown immediate. You'll recall what happens during a shutdown immediate with Oracle 11g. Any active connections are killed, the database is first closed, then dismounted, then the instance shuts down. Note if I try to run help, the help system is not available. To start up, I'll issue startup no mount. Now of course we could just do a startup with nothing to bring us all the way into the database. If I run a query like select star from DBA underscore tables, you notice we get an error 1219, database is not open, queries allowed on fixed tables views only. Aha! So at this point the instance is up, but the database isn't. Now how do we open the database? How do we mount it? Actually, it's not even mounted. You can issue an alter database command with the mount keyword. Now you'll note that I did not need a semicolon for my startup no mount because startup is not an SQL command. Alter is of course SQL, so we need the delimiter. Now the database is mounted but not open, so you'll note that my SQL command still fails. Final step is to alter database open, and at this point we should be open for business. The instance that gives us our system global area, our buffers, our memory structures, our background processes were open. Then we mounted the database, which brought it into action but not open for connections and queries. And now finally, when we opened the database, we now should be able to run that query. I'm going to have to type the command again, and there it is. By the way, when you run a long query and you want to stop it, you can use Control-C. That's your break character, and it works in all operating systems. Command-C in Mac. Now in Windows, as usual, you get a little extra hand-holding. I created a custom Microsoft Management Console earlier that brought in our Oracle Managed Object Snap-in. Let me load that in. And if we expand our server, expand our database, we can right-click the database and select Startup Shutdown options. Now notice also you can bounce the database in Windows using either the Service Control Manager application or the Oracle Managed Objects MMC Snap-in, but there's a Startup Shutdown options command that allows us to customize the NT service properties, which we can get to from the Service Control Manager, as well as the Oracle instance properties, such that we can say when the instance is shut down or stopped through this interface, do we want to do a normal, immediate, or abort? You see what I mean? So this is for those real hardcore graphical user interface people who want to be able to bounce a database without having to know some of these commands. Final startup shutdown related command I want to show you. And this again, it's similar to shutdown abort. You want to use it as a last ditch effort, say during troubleshooting. But if you just want to bounce the database, in other words, restart it, you can use startup force. In fact, I'd be interested to know if force is in the help. How about we do help startup? And let's see, it does give us force as an option. That's kind of cool. But a startup force is a combination of doing a shutdown abort and then a normal startup. So you notice how fast that shutdown occurred. We're already have the instance up. We already have the database mounted. It's a really fast way to bounce the instance, but you only want to use this if you're offline or off time, I should say, and you know you're not going to interrupt any user sessions. Database initialization parameters. I've said several times in my humble or not so humble opinion that you should make sure your Oracle database or your Oracle instance is starting from a server parameter file or SP file instead of the old school P file. Now SP file's been around for a long time, many years, since Oracle 9i, so it shouldn't be a big deal for you to be using the SP file. Specifically, why I think and why many Oracle professionals feel that you should be using the SP file is because number one, it's dynamically maintained. The SP file is a binary format file. You cannot read it directly. Similarly to how the Windows registry, you can't just crack open a registry file outside of using, say, a registry editor because it's just zeros and ones. There's no human readable text. That means the file is integrated deeply into the instance. By contrast, the P file is just a plain text file that can be edited with a plain text editor. It could be gedit or Vim in Linux. It could be Notepad or WordPad in Windows. And that's all well and good. You can use a P file. They work, but you have to bounce or restart the database every time you make a change. By contrast, you can make dynamic changes to at least most, not all, initialization parameters while the instance is running. Another cool thing about SP file is that you can back up both images of the SP file using the Oracle RMAN or Recovery Manager backup and restore tool that we'll learn a lot about later in the course. Finally, you can share the SP file in a clustering, a real application clustering environment, which can be really, really helpful because, let's face it, initialization parameters need to be standardized if you're focusing multiple instances, multiple servers on a single shared database, which is the case with RAC. Now, as far as the naming of these guys, the P file's default name is init.sid.ora. Now, SID, of course, is the name of your database. So in our case, with ORCL being our SID, the text file will be called init.orcl.ora. The SP file is called spfile.sid.ora. And you can make changes, as I said, to the initialization parameters in memory through SQL Plus or any SQL tool using alter system set. Speaking of which, if we need to make a change to an initialization parameter while the instance is running, and understand you can't do that with all initialization parameters. Most of them you can though. You would, from your SQL session, run the command alter system set, then the name of the parameter equals, and then the value that you want to set. And optionally, there's a clause called scope. It's important that you understand this. Let me throw an asterisk up here. If you do not specify the scope clause, then Oracle will default to the both keyword. Now you have to remember that the SP file has two images. It has what's running in memory, the active operating state of the instance in the database, and there's also the binary file that resides on disk. The disk-based image is important because if we restart the Oracle database, we want to make sure in most cases that it picks up any changes we make to initialization parameters. So that's why alter system set defaults to both, which puts your change both in the memory image as well as in the SP file, and that change will persist across restarts. By contrast, there may be some times where you want to change an initialization parameter for the current running instance, but you don't want to affect the server the next time you restart. In that case, you can specify scope equals memory. The other side of the coin is to make a change intentionally that's not going to affect things now in the running state of the server, but you do want it to go into effect at next restart. In that case, you'd specify scope equals SP file. You see? I think it's quite elegant how that works. As a matter of fact, the difference with SP file having a memory and a disk image reminds me very much of the running configuration and startup configuration of Cisco routers and switches. So if you have any experience with that, with the Cisco IOS, then this should be very familiar to you indeed. Now, you can do conversions at any time. That is to say, you can create a P file from SP file just by running the command create P file from SP file. You can also create an SP file from a P file. If something happens to your SP file and you have a P file already backed up, this is actually what I would consider a backup regime, because as you know, we're going to be starting the server with SP file. If we run this command periodically, it ensures that all of the initialization parameters that are stored in SP file get backed up to a plain text copy, similarly to how we can back up a control file to trace to get a plain text text version of those values. We can then replace the SP file with the backup by running create SP file from pfile. Pretty elegant again, huh? Finally, to get metadata about your initialization parameters, of course we have Oracle Enterprise Manager. They have a really nice initialization parameter editor. We can query our data dictionary, our dynamic performance views. There's one in particular called $parameter, and there's also an SQL plus command that we've used a little bit in the training, show parameter, that can show us current values of parameters. Now, as far as the location of your parameter file, depends just a little bit on your operating system. You're going to be at Oracle Home DBS on Nix and Oracle Home Database on Windows. Finally, let's look at some vocabulary with regard to these initialization parameters. You need to understand the difference between basic, advanced, and I'll throw in a third variety called hidden. And then also, in the upper left, I'll cram in static and dynamic. Don't worry though, this isn't difficult at all. It's just learning the Oracle vocabulary. The difference between static initialization parameters and dynamic simply refers to whether the initialization parameter can be changed without a shutdown or startup. That's a static parameter. You have to restart the Oracle instance and Oracle database in order for that change to go into effect. And there are a few key initialization parameters that are static, certainly. Most, though, are dynamic, which means that we can change the in-memory as well as the on-disk SP file. Next, we have basic, advanced, and hidden. Now, these are actually documented by Oracle. I've given you a URL to look at your convenience. Basic parameters are the approximately 30 initialization parameters that any DBA should know. These are the most commonly modified parameters. Advanced parameters are over 300 as of the 11G release. Now, the specific number of initialization parameters is not important for your exam success, and the number of those parameters is going to depend upon the edition of Oracle that you have installed and which optional features like rack, like automatic storage management, etc. you've brought up. But the advanced parameters, according to Oracle, should only be tweaked if you really know what you're doing, number one. Number two, if Oracle support tells you to. And that Oracle support piece comes in here. Similarly to how in most operating systems there are hidden controls that are undocumented, there are plenty of those dealing with troubleshooting and performance optimization. You can read books on this that give you some of that voodoo magic, but the hidden initialization parameters that aren't officially supported or documented can be given to you by Oracle support if you have a support arrangement with them. It's one of those reasons where it can be really worth the money to buy that Oracle support. And just for grins, I've gone to that URL I gave you. It's going to bring you to an article in the Oracle Database Reference Guide called Basic Initialization Parameters. And these are named pretty reasonably. DB block size allows us to specify, well, the default block size for the database. Control files is an initialization parameter that gives us the location of our control files. DB create file dest gives us a default file spec or file path for when we create new data files. Recovery file dest allows us to specify our flash recovery area. There's PGA aggregate target if we're doing manual memory management, SGA target, shared server, undo table space. These are just your basic parameters. In this final demo, we'll look at parameter files and initialization parameters in Oracle Database 11G. Now, when you're coming in as a consultant, you probably first want to know, is this server set to start with the P file or the SP file? And you can find really nice SQL recipes on the web. This is a simple one that I found that pulls data from the $parameter dynamic performance view that simply tells us whether this server is set to start with either a P file or an SP file. And it tells us here SP file. To take a look at some of those parameters, we can grab, well, first let me use a really nice command that's internal to SQL Plus called describe. And let's just run it against the parameter system view. Describe is useful for us because it gives you the schema or the setup. Again, I'm using schema in kind of a fuzzy way. Let's just say the structure of a table or view. And there's some really useful information here. It tells us whether it's modifiable, whether that parameter is instance modifiable. In other words, can you modify the value for that parameter in memory? Is it set to the default value? Is it basic or advanced? Some really, really good stuff here. But at base, you can grab just a couple columns. Like I'll grab name and value. Those are the most common from $parameter, and I'll throw in order by name. Now I'm going to take a little pause here, the pause that refreshes, and address something that's really annoying for newcomers to Oracle. When they run a command, the format oftentimes will look really messed up. Like we're supposed to see a report with 2 columns, aren't we? We want to see the name of the parameter and we want to see its value. But instead we're seeing the column headers, and then underneath we're seeing a number of just duplex couplings. Undo management's the parameter name, auto is the value, undo retention is the parameter name, 900's the value. How can we fix this? Well, I'm glad you asked. What we can do is use the column command. This is part of SQL+. Provide the name of the column, format is the keyword, and then we can specify the number of characters. We can prefix character widths with A. And I'm just going to set name, let's make that 18 characters, and then we'll set value to the format of 20. We can type list to bring back what's in the current SQL+ buffer, which is our select statement. We can run what's in the buffer with the /, and that gives us a little better look. Now, there's some paging issues here. You'll notice that the results are assuming we have only what? 1, 2, 3, maybe 5 or 6 items per page. That's why these column headers are repeating. We'll let that go for now, but at least this gives us a better look at what's going on. So that's something to put in your pipe and smoke. Make sure that you understand that you can on the fly adjust column formats, and you can change to currency style if you want numbers to look prettier, etc. SQL+ gives you lots of help in that regard. Hey, speaking of the list command, which gives you the query that's currently in the buffer, this has to be an SQL query. The list command, or abbreviated as L, isn't going to give you access to SQL+ statements. You also want to know about the edit command and the editor. You should define an editor for yourself. Technically, the name of the parameter is _editor, so it can be define space _editor, but I like to run them together. And for Windows, you can use Notepad or WordPad. For Linux, you can use VI or gedit, whatever. The benefit of adding this to your session is that we now can type edit, and Oracle will bring up whatever is in the buffer in your desired editor. In this case, as you see, it's Notepad, so we can make a change if we want to. Let's just say we want names from vparameter, and the file is called afi.edt.buf, and it actually does exist in the file system. So when you make a change to your long query, this can be very convenient when you're dealing with honkin' long queries with joined tables and lots of stuff going on. I mean, let's face it, it's not fun editing lines when you're in SQL itself. You make your change, make sure you save the file, and then when you come out, you can run L again, and you notice that that query's been updated. Now you're probably wondering, well, that's cool. I can set editor while I'm logged in here, but what happens when I exit out? Now, a way to set parameters for your SQL+ session and have them always be retained without any doubt is to put those directives in your glogin.sql file. glogin is a server-wide file that can allow you to preload all of your customizations for your SQL+ session. Let me quickly step into Windows Explorer. glogin.sql is server-wide. There's also a login.sql that you can use on a per-user basis. You'll notice that the default path is Oracle Home SQL+ admin. And let me open this up really quickly. And it tells us here that glogin or global login is our site profile. In other words, it will affect all users who start SQL+ on this machine. And we can just specify our parameters to customize things like line size, page width, etc. So $parameter is one way to see your initialization parameters. We can also, as you know, use show parameter. If you use show parameter with no keyword, it's going to show you everything. If you know the name of the parameter or even a keyword part of the parameter, you can put that in. So show parameter processes gives us all of our initialization parameters, their data type, and their value. Very similarly to how the Windows registry has registry values, data types, and data values. We can log into Oracle Enterprise Manager. I'm going to log in as sys with the sys DBA privilege. Oracle Enterprise Manager / database control gives us a nice graphical front end to our init parameters. To do that, we'll go to the server page under database configuration, initialization parameters, and you can filter the list by name if you know the name or a partial name, whether it's a basic or advanced parameter, whether it's been modified or would be at its default value, whether it's a dynamically configurable parameter, and then we have lots of different categories. Let's select dynamic no, and that's going to give you parameters that, as you see, cannot be configured in memory. By contrast, if we select dynamic yes, these are parameters that we can customize. You'll note that these text boxes are all selectable while the instance is running. All right, so that's the difference between static and dynamic. If we scroll to the bottom, you'll note that this table actually consists of 2 pages. Current refers to the in-memory image of the SP file. The SP file tab gives us access to everything, and these changes aren't going to go into effect until we bounce or restart the database, which we can do if we come back to the database homepage. On the general area, note that this tells us the status, the uptime, the instance name, version, host name, and listener. We can get to our listener properties from OEM as well, and then if you want to, you can shut down the database. Now, in order to shut down, you have to provide both host OS credentials as well as database credentials, and then, of course, how you're going to shut down the database. Pretty intense stuff. Let's come back to SQL Plus and let's make a change. First, I want to show the difference between the scope keywords. So if we show the parameter processes, you'll see that there is a parameter called processes and it's set to 150. If we want to change this in memory, we can try an alter system set command space the name of the parameter equals and then the name of the value. So let's just make this 200. Unfortunately, sure enough, we ran into an initialization parameter that cannot be modified in memory. What do you think about that? Let's try something a little different then. Alter system processes. Let's actually go in the other direction, 125, and say scope equals pfile. And I have a syntax error. Alter system space set. And what I did just there is use my up arrow to bring back my previous statement. Then I arrowed over, added the command. And yet again, syntax error. I'm really on the ball this morning. Processes equal 125. And if we do one more time with feeling, not pfile, but spfile, I finally get a system altered. Now I'm leaving all this in. I could trim all this from the Nugget video just to show you how cool I am. You'd never know that I made these mistakes. I want you to see these mistakes so you don't feel weird as you're going through learning Oracle and you're making these. Everybody makes these kind of mistakes. There's just too much to keep straight to avoid human error 100% of the time. Now, if we show parameter processes again, you see that it's 150, don't you? Because we made this change to the static parameter in the SP file on disk. Now, what does that SP file look like? Why don't we find out by saying create P file from SP file, file created. So if we go into Windows Explorer, Oracle Home, Database, we will see not just our SP file sid.ora, this is our binary server parameter file that we cannot view in Notepad despite the icon here. And now we have an init oracle.ora that I'll open with WordPad. If we do a search here, we can see processes is in fact set to 125. So in order to make that go into effect, we're going to have to bounce the database, aren't we? Well, before we do that, I promised you that I would show you how to multiplex the control file. In other words, put your control file copies on more than one disk. I now have a separate drive besides my OS drive. Let me open up my computer. I have an O drive called data, and I've created an OFA compliant path called O app Oracle or a data. And what we can do here is first of all show the parameter control_files. if I can spell, and it tells us the 2 copies are currently located under Oracle Aura Data on the C drive. Well, that's not what we want. Now, what are we going to have to do before we multiplex our control files? Number one, we're going to need to take our control2.ctl and move it to our O drive. But before we move the file, what do we have to do? Hope you know this. We have to shut down. I'm going to do a shutdown immediate because remember, in order to access or move around these control files, we can't have the instance or the database open. I hope that makes sense to you. So why don't I open up a Windows Explorer window, C App, Oracle, Aura Data, ORCL. I'm going to cut Control2CTL, go to my O drive, paste that file in. Now that we've shut down the instance in the database, it's a good thing that we have our plain text init.aura file. Comes in handy for things like control file multiplexing. In this case, we're going to find the control files directive, which you see right here, and we're simply going to change the path to control2.ctl by making it o:\app/Oracle, Aura Data, ORCL, etc. You see what I mean? Save it. Now what do we need to do? Think logically with me. The instance is shut down and we've made the change in the init.aura file, not the SP file. What we can do is create SP file from P file. File created. So now let's start up. We're up and running. Let's show parameter control files. And sure enough, our path is correct. Good deal. So I guess there are some good reasons to keep that P file. This is a good one. Admittedly, you're only going to multiplex your control files once over the lifetime of your system. Managing the Oracle instance, part 1 of 2 review. By this point, you should understand the phases of database startup and shutdown. You should know the difference with startup, for instance, between no mount, mount, and open, and you should understand how to gracefully shut down an Oracle database, as well as some ways that are a little bit more aggressive but sometimes necessary. We also covered initialization parameters. You should understand very intimately the advantages or disadvantages of the SP file versus the P file, how to access them, how to set initialization parameters both online as well as offline, and what the effect of those changes will look like. I hope that this has been informative for you, and I'd like to thank you for viewing.